my peeps. The voice is back. Today's podcast will cover page 106, problems 3 and 4.
What's up, Algebra Nation? Let's work through another problem. Here's what we have. Problem 3 says, what is the quotient of the expression below? I guess it's asking, right? It's a question. What is the quotient of the expression below? So, quotient here, this is the important keyword, quotient. What does quotient mean? Well, quotient means divide. That's what quotient tells us. We need to divide something here. So, when we have a fraction like we do here, that's essentially what we're doing, is we're dividing. So if they ask us to find the quotient, what they really want us to do is they want us to simplify this fraction here. All right, so we've got a lot going on here. We have to go, remember, order of operations here. We have to go by PEMDAS. Please excuse my dumb, annoying sister. That's not very nice. Please excuse my dear Aunt Sally, right? Okay, so first thing we need to do is take care of these parentheses. We have parentheses with an exponent on them. So what we're going to have to do is we're going to have to make sure that we take that exponent, place it on each one of the terms inside. All right, so it's going to look something like this. We're going to have 3 cubed, then x to the 4th cubed, and then y to the 3rd also cubed. So basically just push that exponent through to everything inside those parentheses. And then at the bottom we still have 3x squared. All right, so the first thing we have here is 3 cubed. Let's go ahead and simplify that. Or, yeah, let's go ahead and do that. We can go ahead and multiply that out. So 3 times 3 is 9, times 3 is 27. Then we have x to the 4th raised to the 3rd. So whenever we raise an exponent to an exponent, remember we wouldn't do 4 to the 3rd. Since this is an exponent and it has its own exponent, we do a step down. So here we multiply those two together. So that gives us x to the 12th, and then y to the 3rd to the 3rd. Again, we're going to multiply those together to give us y to the 9th. And then the bottom, we still have 3x squared. All right, now that we have our exponent taken care of, now we can go ahead and do multiplying or dividing. Well, we're not going to multiply anything across the top, but we do have division here. So let's go ahead and do our division. All right, so remember, we can only divide like terms. So we have 27 and 3. Those are both coefficients. They're both just numbers, what that means. So we have 27 over 3. We can actually simplify that. If you divide 27 by 3, you get 9 back out. And then we have x to the 12th on top and x squared on the bottom. How do we deal with that? Okay, so I know that when I multiply together, I add the exponents, right? If I'm multiplying, say, x to the 3rd and x to the 4th, then I would add their exponents together to give me the result. But here I'm not multiplying, I'm dividing, so I must do, well, dividing is the opposite of multiplying, so I have to do the opposite. I have to subtract 2 from 12. So I do x to the 12 minus 2. And then I have y to the 9th on top. I don't have any y's on bottom, so nothing's going to happen to y there. All right, then the last thing I have to do is go ahead and simplify that exponent. So I have 9, x to the 12 minus 2 gives me 10, and y gives me 9. All right, so that's a correct way to go through the problem. That's one way to do it. Now, there was one point earlier in the video, and I was like, well, there is a shortcut we can do, is what I was going to say, and I'll go ahead and mention that now. Notice here we have 3 to the 3rd. On the bottom, we have 3 to the 1st. So what we could have done is we could have subtracted that exponent, the exponent on the bottom, from the one on top. So we could do 3 minus 1, and that would give us 3 squared. If we combine those together, we'd get 3 squared. And then notice what we ended up with. We ended up with 3 squared, or 9, in our answer. So that's a little bit of a shortcut we could have taken instead of multiplying that all out to give us 27 on top. But you don't have to do that. This is the safest way to go through this problem.
Ready for a brain break? If you do this on the EOC, you will get a touchdown / $3.99 or higher, baby. problem number 4.
What's up, Algebra Nation? Let's work through another question. So here's what we have. We're given an expression. The expression, bunch of stuff, is equivalent to which of the following, and then we have some answer choices. So again, we have a multiple choice question. Sometimes it's best to look at the answer choice to get an idea of the direction you want to go. Now, if I'm looking at what we're given and I'm looking at what we have down here, I notice that everything down here, well, none of these, I guess you could say, has parentheses on them. So I've dealt with the parentheses somehow and getting from up here down to our answer choices. So let's go ahead and deal with those parentheses. How do we do it? Well, first of all, I'll go ahead and write this problem down. And I have parentheses with an exponent on them. So what that really means, what I'm doing there is I'm doing m to the 6th, n to the negative 5th, q to the 3rd, and I'm multiplying it by itself twice. So I'm multiplying once by itself, but I have 2 of these terms. I could actually write it again, m to the 6th, oops, it's an n, m to the 6th, n to the negative 5th, and q to the 3rd. All right, so now I see that I just have multiplication of all of these variables with exponents on them, and when I multiply these together, again, I take the ones with the same base, and I add their exponents. So I have m to the 6th and m to the 6th, so I'm going to do m to the 6 plus 6, which is going to be m to the 12th. And I do the same thing with n. I have n to the negative 5th minus 5. And then I have q to the 3rd plus 3. All right, I'll go ahead and simplify that. I have m to the 12th, n to the negative 10th, and q to the 6th. Now, there's another way I could have gotten here. I'm going to pause real quick before we get our answer. Another way I could have gotten here, remember, is when I raise an exponent to an exponent, I just multiply them together. So I could have done m to the 6th times 2 gives me 12, n to the negative 5th times 2 gives me negative 10, and q to the 3rd times 2 gives me q to the 6th. So I could go about it that way as well. A few different ways to go through it. Use whichever one you like. All right, so here I've got this, this answer here. Really, I have a simplified answer. But as I'm looking at these answer choices, I don't see mine exactly. This first one looks pretty close. So I might be thinking, well, maybe my negative was wrong. But no, that negative was right. I did everything right with that negative. So I should have n to the negative 10th. This is where we have to pull in one more rule here. There's one more rule, and that's for negative exponents. Remember, a negative exponent, for instance, when you have, say, x to the negative 2nd, we can rewrite that as 1 over x squared. That's how we deal with negative exponents. It just means stick it on the bottom. Stick it on the bottom. Doesn't mean the number is negative. It just means we're going to put it on the bottom. We're going to make a fraction. All right, so our negative exponent we can deal with just like that. We have m to the 12th times 1 over n to the 10th times q to the 6th. We're getting close, but we don't exactly have one of the answer choices here. So the last thing we can do is we can multiply m to the 12th by 1 and by q to the 6th. So m to the 12th times 1 times q to the 6th gives us m to the 12th, q to the 6th. And on the bottom, we have n to the 10th. And that right there is our answer choice. Our answer is going to be answer choice C. All right, so that's the way to work through that problem. If you have any other questions on it, feel